You ready for part three? Let's go, part three. Okay, part three is going to be how to make the map. And so this is section one on the report down there. And so this is my little map that we screen captured. If you didn't see where we got this, go back to video number one, part one, and watch how we got this. And then part two was on interpreting the blast results. And now we're going to make this map. And so let's copy this thing. And now you can put this into any number of programs. I'm going to use Microsoft PowerPoint, but it would work in any of the open office things that you can get online. Yeah, it works in a lot of things. Whatever lets you make slides and do little drawings is going to be great. And so let's first get rid of all this junk they left on my screen. Okay, and I've already copied it, so I'll paste it on there. And so now that's great. I don't need this anymore. Okay, and so what we've got here is kind of an outline. We've already got a really nice scale bar on the bottom, and I would say let's just keep this scale bar. Why reinvent that wheel? So Control Paste, let's copy that, and in PowerPoint you can just crop it down, but you can crop it in any program that you could possibly be using. Okay, it's still got a little bit of green in there, and I think that's kind of ugly. So we're gonna go something like that, brighten it up, and then we're going to we got a color map here. I'm going to turn that into a black and white thing. And so yeah, great. There, I have just made the black and white version of this. You don't have to do that. I'm just doing it because it makes it look neat and tidy. Okay, your next job is going to be you're going to put little rectangles on here that trace over the shapes of these things. And the reason why you're going to do that is because these are all the genes, and it's showing you the direction they go, which is very nice. And we want to be able to map these and say something about them. And so we're going to need to zoom right into these. And let's just adjust that until it's just the right size. And we'll adjust that. And there. Okay. And on this one, yeah, you try and get it pretty good, but it's not a case where it has to be absolutely perfect. Okay, and we just need to make sure they start and stop at the same place as the pictures on the screen, because that is where the genes we're actually working with start and stop. Oops. Let's put that one back up and make a little, there we go. That's a good end spot for there. And let's get this over to the edge. Awesome. Open reading frame 9. Yeah, that looks good. And yeah, I just keep copying and pasting these little rectangles down. And whatever's your favorite method of drawing, I don't know, is going to be fine. You could even theoretically make this thing on paper and then scan it in and then put it in your paper. That would be totally fine for this. I'm just a little faster on PowerPoint than I am by hand, and so that's the way I'm going to do it. Okay, we'll use that for number 8 over there. Here, let's move over. And I think our first end was right on this, and there's our second end. And let's get this guy on. Great. Etc. Okay, and so you see how it's done, and you just keep doing this for the rest of it. Let's just map out the front part of this. So I'll write on this, open reading frame 2, and that text is too big, so let's drop it down a couple sizes. That's great. And so let's take everything, and I think Calibri is an ugly font, but you know what? You use whatever makes you happy. That is fine. So there we go. An Arial 10, that makes me happy. Yeah. Okay, and so ORF 13, ORF 6, open reading frame 9, open reading frame 7, and open reading frame 3, reading frame 12, and oh yeah. So we had that end right, and we completely got that end wrong. There we go. That's about right. And it is open reading frame 8. Okay, awesome. And so these are things that we have in there. And let's get open reading frame 1 just so we can start out with that. Okay, that's about the right start position. There's the right end position. Okay, and I'm trying to be careful and just move the middle box when I'm resizing these things so that they all stay the same height. If you mess up and they get different heights, that's okay. You can just select them all. Boom, 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 boom. There we go. And in PowerPoint, it'll give you an option to adjust the heights. So you can take them all down or up as you like. Yeah, that's fine. Okay, so with that, we can move these things down. So let's just select all, chop that, and move them down. There we go. Okay, now we want to separate these into ones that are going forward and ones that are going backwards. So look at the little arrow in there. And okay, so I'll do this by bringing all the ones with a forward arrow up. And so I'm not moving them around. I'm just pushing the up and down arrows on the keyboard. I'm like selecting it and then moving it around that way. Because otherwise I know I would not get them in the right spot. And after I was so careful to get them all the right size, you know, this is a nice thing to do. So I'm just moving up and down with the keyboard. And let's see, 3 is going forward, 12 is going backwards, 8 is going forward, and it's overlapping 3, so let's just show it above or below 3. I'll do it above. And this is Open Reading Frame 1. I don't know why I said it was 8. And 1 is also going in this same direction, and so there we go. We just want to make sure we can see everything. And so let's put a little label on here, and we can say that these are forward open reading frames over here. Great. And we have our reverse open reading frames over here. Awesome. And those are much bigger and uglier than they need to be, so let's take those down to Arial 10 as well, because that makes me happy. But you pick your own favorite font. That's fine. Okay, so there we go. Forward open reading frames, reverse open reading frames, and we got a nice scale, and all these things are to scale. They are exactly the size they should be. So you could look at this and say, well, it goes from about 1,500 to about 700, so it's about 800 nucleotides. And so 800 nucleotides, divide that by 3 to figure out how big the protein is. And that is 267-ish. And so if we want to check if that is right and to scale, we can go over here and see it's open reading frame 13. And there we go. So it is actually 237. So that just means I was a little bad at estimating, but it is actually a pretty good scale map. And so that's good. Oh, actually, yeah, it goes from 800, not 700. Silly me, yeah. So it should be about 230, and it is 230. Okay, so we got our forwards, we got our reverses, great. And now we have to start populating these things, and you just do that from the information that's already on here. And you make it look however you want, as long as you've got all the information there. So I see, the first one I've got here is Open Reading Frame 2, and so let's see what Open Reading Frame 2 is. On Open Reading Frame Finder, it says Open Reading Frame 2 right there is, there we go. Okay, and so, yeah, we already knew where it was. That's dumb. So let's look here. And so they're numbered correctly. So Open Reading Frame 2 is this one. Yeah, 779, 1762. Great. And so this is saying that Open Reading Frame 2 is a methionine tRNA formal transferase. Great. Okay, it's fine. So we can write that down now. So this is methionine tRNA, and methionine, that's fine, of methionine, tRNA formal transferase, and what type was it? I forget. Oh, it doesn't give us a name. That's fine. But it's from Ralstonia. Okay, and anything that is a genus and species name is supposed to be in italics. That's just the way we do it. And so let's center that. It is usually Control E or Command E. Control E on a PC, Command E on a Mac. If you have the whole box selected, it will put everything in aligned in the middle. So there we go. And so this is what we think it is, but the most important part is why should we believe this? And so the e-value is 0, 0.0. E equals 0, 0.0. And we don't need that to be italic, and so there. Let's make it not italic, and that's looking great. And so let's now make this less Calibri and more Arial 10. And oops. Oh, there we go. There we go. Looking good. So that is Open Reading Frame 2, and boom, we can put it right there. Now this thing we can actually delete. We don't need that anymore. And so let's go on. Let's look at Open Reading Frame 13. Great. So we can just copy our little template down here, and let's go see what Open Reading Frame 13 is. So scroll down to 13, and 13 is at the bottom, and I remember in mine, the bottom is full of trash. It can be totally different in yours. It just depends what order the genes come in. And so this thing is probably a hypothetical protein, and it's most similar to a Cumulibacter, which I've never heard of before, or it's similar to Pseudomonas syringae, which is actually a pretty close relative of Ralstonia. And so, oh, I like that. We're covering the whole thing. So query cover is how much of the gene you were able to match, of the protein. We were able to match 94%, and the e-value is the same as that one. It's a little, not quite as identical, but it's actually pretty good. I'll take that. So I'm going to go with the second hit here because it covers a little bit more of the query of the thing that we put in. And you would be okay putting any of these top 4 in because number 5 is where the stats go right off a cliff. And we got an e-value of 1.3 that we can't believe anymore. So let's see. Hypothetical protein ALP24. Okay. So it is now a hypothetical protein ALP24. Is that right? ALP24 underscore 05654 underscore 05654. Sweet. All right. Now stretch that box out a little bit. There we go. So now it all fits. There we go. For some reason, it was taking the top line as not centered and the rest of the lines as centered, which is annoying. Okay, and so this was not from Ralstonia. This was from Pseudomonas syringae. And I don't think it had a... Oh, no, Pathovar, APTATA, aptata. So Pathovar, which means a version that is pathogenic, causes disease in something called aptata. And I have no idea, but if you were to look that up... Actually, let's look that up. Aptata. It's probably some kind of plant. Well, no, that's a moth, and that's a species. I don't know. I don't know what it means. You know what? We could Google it. We could look it up, but I'm not going to do that because it doesn't really matter. And the e-value is pretty bad, but not terrible here. So let's look and see what our e-value was and get that copied down accurately. So it's 4 times 10 to the negative 16. So e equals, so you can do 4e minus 16. Make sure you get the minus in there. Or if you want to be fancy, you can do 4, and you can put in a times sign symbol. And there it is, the times sign. 4 times 10 to the power of negative 16. Oops, 16. And you're supposed to express exponents like that. And so, oh my gosh, look how pretty that looks. And you don't have to do that, but it does look pretty. Yeah, I'll see it and I'll smile. Yeah, I'll think, yeah, wow, this person gets it. Okay, and so it's like that. And so for Open Reading Frame 6, we don't really have room to put it in there, so let's just put a little line in that says that it goes to there. And then we'll write what Open Reading Frame 6 is up above it. So there we go, etc. And this is basically what you're going to do. Let's do 6, and then we'll be done with this section. Or rather, I'll be done with this video. Okay, open frame 6. I like all that red. It means it's going to be a good hit probably. And yes, I like that E value very much. Okay, and so this is our Lice E family translocator. Great. And so it is a Lice E family translocator. Mostonia solanacearum, and E value is not 0. It is some number times something else. So let's just copy that from before. Boop. Okay, and what was the amount? 3 times 10 to the negative 156. 156 and 3. Bam. Done. And so on. You just keep going. Tick, 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 all the way until the end. And you get all the nice stats there for every little thing. And then, yeah, that is basically the map section. Now, a good figure, and let's zoom out here a little bit, a good figure is going to need a legend as well. Now, if your figure is too big, if you don't like it, what you can do is group everything together. And so the way you would find that would be you would select it all, and then if you right-click on it, or on a Mac you do a two-finger click, it brings up the option to group it. That is one way. I believe it is also up here in the, let's see, format now. Edit now. Tools. I don't know. Oh, actually, it would be up here in your bar. I think it's the arrange thing. There we go. You can group it there as well. So different ways to do that. And if you don't know how to group it, you put, you go to your help and you say, how do I group things? Group. And so boom, it'll tell you this is how you group it. So you can click an item, click the arrange menu, and click group is right there, or it's telling you the keyboard command that can do the same thing. And so that's fine. So carry on, and boom. When you're done with that, you can just scrunchy it down a little bit. And if it starts to look ugly, you can stretchy it a little bit taller. There we go. So, and then if it still is sort of piled up, you can adjust it a little bit, or you can drop your font size down a little bit until it actually looks better. Yeah, actually, you know what? I preferred this thing before. We'll just take a picture of it there. Once you have this thing completely done, you're going to save it definitely. So whatever, save as a PowerPoint presentation. And then when you're totally done with all your edits on there, you're going to export this thing as PDF is fine, or you can do like a TIFF image or a portable network graphics. That is fine. I would stay away from a JPEG if you can. You lose some resolution when you do that sometimes. Depends on how PowerPoint is implementing it. But portable network graphics will never lose any resolution, and TIFF usually won't. I'll do a PNG. And I only want to save the current slide, and I don't like that. That's real low. So I'm going to save it at a little higher resolution, 1300 by 731. And so, boom, it's going to be exported. Let's give it a better name than presentation 1. Let's call it map section. And then my section was the example. Fine, looking good. And I'll save it on my desktop. Boom. And there it is. And so now we're done with this, and I'll just minimize that down, and it should be here, and there we go. So I got a PNG of this thing, and we can paste this into a report. So we would just select all, copy, get a report open, make a nice new document, and then paste that in. Now it's got all this white space on it, but that's okay, because Microsoft and any other thing that lets you paste pictures will let you crop them. So you just got to dig around and figure out how you do that. And so you're going to crop and get rid of all that extra white space that we don't need. Make it nice and tight, because you've really got a lot of information to fit into 2 pages of this report. And so you can't be getting all loosey-goosey, you know, leaving stuff hanging out. Okay, there we go. And every good figure ends with a figure legend. So figure, and a figure legend looks like this. So you give it a name, figure 1, which it is. And the first sentence says, it doesn't have to be a complete sentence, but it has to say what this is. So this is a map of genome section, whatever yours is. Mine is example. Yours will be, you know, number 7 or something. from unknown bacteria. And that's great. And you don't want to mention the class on this, so don't mention Biology 1306, and you don't want to mention your name or my name or anything, because we're going to send this in to the examiners, and they want to be able to do this fairly and objectively. So no names, keep it anonymous for now. Okay, and so we need that, and then we need an explanation of whatever it is. So genes are shown to scale and with respect to direction on the genomic DNA as assembled. Let's see. We got gene numbers, which are ORF 1 to 13 in my case. Let's see. Shown with statistics from what program did we use? It was BLAST. It was actually Protein BLAST. Yeah, and I think that's going to be good. So better than statistics, we could say with homologs and e-values taken from protein blast, which is the kind of blast that we did. So yeah, something like that does the job. So you got to have a title, figure something. You got to have the what it's actually showing. And most journals, they'll put those two bits in bold so they stand out. And then you'll go through and show exactly what this is. Now, if you use different colors for like the forward and reverse open reading frames, which is a totally good idea, wish I'd thought of it earlier, then you say in here, the pink ones are in the reverse orientation and the blue ones are in the forward orientation, or whatever colors you want to use. Yeah, and indicate they're shown to scale. And we need to say what the scale bar is. So scale bar is in nucleotides. Yeah, because it's single nucleotides. So you can read there, and the end was 10,421. There's just no genes in mine in the last about 4,000 nucleotides of that thing, which is, I don't know, that makes me suspicious. Makes me think that this bit is misassembled, or there's something wrong here. Something didn't quite work out right, but I don't know. And it's not your job to figure out what went wrong. It's your job to do your best version of annotation on these. Now, other little tips, other things you could do, you could, instead of making little rectangles, you could make little arrows. So I can show you how to do that. So on these, there, we'll make that a little bit bigger in your shapes menu, and it'll be the same no matter what program you're using. They'll have something like that. Make a little arrow, and you can just make those the right size and right length. Yeah, that's pretty good. So open reading frame 7, boom, right on there. And again, I'm not a fan of that font or size. And so, yeah, you could replace all of these with rectangles with little arrows. And that'd be fine. That would show direction very simply in a way that you wouldn't really have to explain, a way that would just, bam, make sense for everybody that was doing it. But whatever you do, you want to do them all pretty much the same way, unless you've got maybe 5 genes that do one thing, and you can give them all a single color, and if you've got some other genes that do something else, you give them a different color. That's totally acceptable. Or genes that have reasonable homologs, we could code all of those in particular color. So let's ungroup these so we can work on them separately. And so all of these, I remember, had really nice homologs, and so we could color them. Ugh, the grossest orange color ever. Let's not do that. Red, ooh, bold. Yeah, okay. And then these things which did not have good homologs, we could leave those in blue. That would be fine. Or you can make them gray or something. whatever just is a sort of a wimpy, washed out color that indicates that there's nothing interesting to see here. Yeah, however you want to visually encode that. And it looks like part of the word reverse was hanging off the edge of my little graphic, and so there we moved it over. And bam, looking much better, and so whatever, we can do the same thing. Okay, so that's a little primer on what to do for the map section. You are generally just responsible for producing this little map infographic that has all the information that we need on it. Like what kind of thing it is, what's it supposedly from, and what's the e-value. And then if we have this whole thing laid out, you would be able to see that everything that has a good e-value on my particular chunk of the genome happens to be pointing in the same direction. So they're all pointing in the forward direction. And everything that has a bad e-value is pointing in the reverse direction. And everything that has a good e-value is also from Ralstonia solanacearum, whereas everything that's got a bad e-value is going to be from different random bacteria because we've got bad matches to uncertain things, in the bad genes. And so all the good data is pointing toward Ralstonia, and so you can be confident that this is a bacterium that is like Ralstonia solanacearum, I would say. And you can pass that information over to the person that is writing the sort of book report section. I think that's section number 3 on the ecology of this thing, and they can go start pulling papers on Ralstonia solanacearum, and learn about that, and then tell me what they found. Okay, that is the end of this section. Thank you very much.